Okay, we are in advanced math, trig, mod 7. Today is Thursday, April 16th. The title of today's notes, put systems of conics at the top. Guys, we've been through 4 days of note-taking sessions and learning about drawing different conic sections. We did circles, ellipses, hyperbolas, and parabolas. We're finishing up that unit with something at the end of the chapter that really preps you for calculus. So whether you're taking calculus or not next year, this is an interesting topic. We're only going to do 2 problems. It's kind of a let's end the chapter by showing you how this works kind of thing. I'm going to give you a conic section and a conic section and simply ask the question, where do they intersect? Okay? I'm going to do 2 problems total. I'm going to do one on the front of my paper, one on the back of my paper. Guys, this is good stuff. It's interesting, something very important for next year. It's kind of intended to kind of wrap up our chapter on conic sections. So I'm going to be a nice guy today and ask, all you got to do is really take a good set of notes for this problem and then write out step by step everything we're going to do on the second one. And then all you've got to do is take me a picture of today's notes to prove you followed along, you copied them down like you were supposed to, and you got the goal accomplished of introducing you to a system of conic sections. You'll shoot me a picture of your finished notes, and you get a 4 out of 4 daily grade just for turning in your notes. There's no extra homework. You don't have to do any problems on your own. So it's important to just kind of focus, pay attention, stay with me and get these done. And shoot me a picture of all the steps and the details when we're finished, okay? So hang in there. Here we go. All right. If you look at this, I'm going to go fairly quickly here. I've got an x squared plus a y squared equals 36. Because there's a plus and because they're both squared, you're thinking that's either a circle or an ellipse. Because the coefficients are different, that tells you that this is an ellipse. And all ellipses, remember, have to equal 1. So my first thought is let's divide everything by 36 to get this into standard form. So that's going to be 4 over 36, and that's 9 over 36. So think with me here. Wouldn't that be x squared over 9 plus what? Y squared over 4 equals 1. Okay? Now, the other one is going to be what? Since there's a minus in the middle, that's a hyperbola, correct? So I'm going to also divide everything by 36 to get it into standard form, because you agree it's got to equal 1. I end up with x squared over 4 minus y squared over what? 9, because you're cross-canceling the 4 with the 36, equals 1. So I've got an ellipse and a hyperbola, and I want to know where do they intersect. Well, let's draw a quick sketch here. If they want to know where do they intersect, doesn't it make sense? We draw a quick picture, draw our oval, draw our hyperbola, and try to see how many times they intersect each other. So if I draw a pretty neat graph here, it's pretty obvious they both have good old x squared and good old y squared, correct? So the centers of each are 0, 0. So I've got an ellipse centered on 0, 0. The x squared has a 9 under it, so I'm going to go right 3 and left 3. The y squared has a 4 under it, so I go to the y-axis and go up 2 and down 2. And I draw a nice, neat ellipse, oval shape that looks like that. So far, so good. The hyperbola, the center is also 0, 0. The x squared has a 4 under it, so I go right 2 and left 2. The y squared has a 9 under it, so I go up 3 and down 3. And remember, because it's a hyperbola, we're going to start at this dot. Look where my pen's at. I'm going to make a corner, go to this dot. Look where my pen's at. Make a corner and a corner. I've got an imaginary line and an imaginary line, the two asymptotes. And remember the rule, because the x squared is first, this hyperbola opens to the right and to the left. So if you want to pause and make sure your picture's nice and neat, heck, it looks like a football, and those hyperbolas are the strings on the football. Where do they intersect? Well, it's pretty obvious. They intersect one time right here in quadrant 1, one time here in quadrant 2, one time in quadrant 3, oh my gosh, and one time in quadrant 4. Name the 4 points of intersection. How would you do that? Well, if I took a look at the original problem, watch how easy this is, guys. It should bring back memories from last year when you solved systems of equations. Doesn't that say 4x squared plus 9y squared equals 36? This one says 9x squared minus 4y squared equals 36. Remember a technique called the elimination technique, where we're going to try to make one of the letters get eliminated and cancel out from our system? Well, think about it. The y squareds are already opposites, aren't they? If I want them to cancel each other out and disappear and be eliminated, couldn't I multiply that whole thing by 4 and multiply this whole thing by 9? And you're thinking, wait, what's he doing here? Isn't my goal to make the y squareds cancel and be eliminated? So watch this. If I multiply that entire equation by 4, I get 16x squared plus what? I'm timesing everything by 4. Plus 36y squared equals, oh boy, I've got my calculator here. I'm going to push 4 times 36, and I'm going to get 144. If I multiply the second equation, the hyperbola, by 9, 9 times him and 9 times him and 9 times him, I'm going to get 81x squared minus 36y squared equals, and if I push 9 times 36, equals 324. Oh my gosh, so I'm going to draw a line. And do you agree that the 36y squareds are opposites? They're canceling out from the problem. I'm going to add my columns and get what? 97x squared equals, what would that be? 468. Divide by 97. I get x squared equals, again, go to my calculator, hit 468 divided by 97. Giving me 4.824, etc. Now I'm just going to leave that number on my screen because, of course, to get that x by itself, I got to what? Square root both sides, don't I? So if I square root both sides, I'm going to square root the number that's on my screen. So square root of that answer gives me, now notice I'm square rooting the number, so it's plus or minus 2.2 to the nearest tenth. Now think about it. That makes sense, doesn't it? Look back at that picture. Remember when I said, where do these two things intersect? And I'm looking in quadrant 1. It's certainly a little bit to the right of 2, isn't it? And then up a little bit. So this guy has an x-coordinate of 2.2, comma. Now, how tall up do they intersect? What's my y-coordinate? Couldn't I now take that 2.2, and plug that in for x right here? And I should be able to solve for y and get the missing y-coordinate. So guys, obviously if I take 2.2 and I go plug it in for this x right here, 2.2 squared, well, I'm going to push 2.2 squared on my calculator. I'm getting 4.84, but then I got to times that by the 4. Agreed? So I'm going to take 4.84 times 4, giving me 19.36 plus 9y squared equals 36. I'm going to minus over the 19.36. So calculator-wise, I'm going to push 36 minus 19.36, getting 16.64. I got to divide by 9. You're with me here. Y squared equals, I'm pushing 16.64 divided by 9. I'm getting 1.849. That's on my screen. I'm leaving that on my screen because I'm going to square root both sides now. And when I do square root both sides, I get plus or minus. So I'm square rooting. I hope you're doing this on your calculator with me. I'm square rooting that last answer and getting 1.36. Oh, so back to the first quadrant. That point of intersection was right, 2.2, and up 1.36. And those are my two answers for my X and Y coordinates. All you've got to do now is go to each quadrant and write down those answers based on the direction you're heading. So do you agree this second quadrant, since it's left and up, would be negative 2.2, comma 1.36. Oh, this third quadrant point of intersection is left and down, so they're both negative, agreed? Negative 2.2 and negative 1.36. And then finally, this last one in quadrant 4, since it's right and down, is 2.2, comma negative 1.36. And I found all 4 points of intersection. So when you get to calculus next year, when your teacher colors in everything in between the hyperbolas and says, whoa, what's the area that I just colored in? Well, you can't go back to geometry and use an area formula, right? Because it's not one of our normal shapes. You've got to actually take that area. To figure out that area, you're going to take each of these conic sections and you're going to do a technique in calculus called integration. And to integrate and get a correct answer, you have to know how tall those dots are. Oh my gosh. And how far to the left and right those dots are. So the points of intersection, as you move forward into higher level math, become important questions. Okay, and you can't find where they intersect if you can't even draw it accurately. Okay, now all we're going to do to finish this, I'm not going to do the entire problem. We're just going to set up what you would do to attack one like this. Again, problem number 2, y squared equals 8x. And then 4 parentheses x plus 2 squared plus 4y squared equals 64. Again, the question of the day, where do they intersect? All I want to do is sketch it and discuss how you would get started attacking the algebra that's involved to find these points of intersection when you have to next year. So here we go. Now, certainly this first one just has one letter squared and the other letters not squared. So this is good review anyway. Think back to yesterday when we graphed parabolas. Do you guys agree that this is a parabola? Now the y is squared, telling me it opens either what? I'll let you think about this. Either right or left, and since the 8's a positive number, it's going to open to the right. The vertex, certainly, since it's good old y and good old x and there's no numbers attached to them, is 0, 0. Agreed? So I'm going to put a dot on the origin. That's my vertex. It's pointing to the right. Remember, we always took the formula for p and set it equal to that number. So dividing by 4, p would be 2. So follow the bouncing pen. There's an important point that's 2 units to the right of the vertex. There's a point that's 2 units to the right of the vertex. So I go right 2. There's the important point. And there's an imaginary line going through there indicating how wide this parabola is. And that line is a total of 8, isn't it? So I'm going to go up 4 from that important point and down 4. And I'm going to connect them up. And I've got my parabola. Now look at the second conic section. There's a plus in the middle. It's got an x squared and a y squared, so it's either an ellipse or a circle, right? Can't be a hyperbola. Because the coefficients are both the same, a 4 and a 4, that tells me it's a circle, if you think back to the first day of conics. So I'm going to divide both sides by 4. The 4's will all cancel on the left, giving me x plus 2 squared plus y squared equals, what is that, 16. Agreed? So the center of this circle is at what? What's the opposite of x plus 2? Negative 2. And since it's plain old y squared, I'm going to put a 0 there. So negative 2, 0 is the center of my circle. And since that number to the right ended up being a 16, that tells me that the radius is what? Square root of 16 is 4. So I'm going to go right 4. Let's be right through that point. Left 4. Up 4. And down 4. So when I draw my circle, okay, whoops, missed my dot. Bam. Do you agree that that circle and that parabola intersect only twice? There's one answer. There's the other answer. And our goal would be to seek what are those two ordered pairs. Now, careful. All I'm going to do is remind you how we would start this, and we'll stop at that point. Hey, guys, you are not going to line up your equations and use the elimination technique. How come? Well, the circle had an x squared and a y squared, but the parabola only has one letter squared, doesn't it? So instead of using the elimination technique and lining up your values, here's what you'd have to do. You'd have to take that original problem, y squared equals 8x. Now think about it. Since y squared equals 8x, couldn't you take that 8x and put it in place of that y squared right there? Think about it. This would end up saying x plus 2 squared plus, and then it says y squared, but the y squared is equal to 8x. So it's getting replaced by 8x equals 16. And then you could square the x plus 2. You'd end up with x squared plus 4x plus 4 plus 8x equals 16. Combine like terms, move over the 16. You'd probably have to use the quadratic formula because it won't factor just to get your two x coordinates of those points of intersection. Okay, again, this is more complicated stuff. The goal was to end the chapter with something like this to kind of give a sneak peek to what you could see either in calculus or maybe a higher level of college algebra. But bottom line is, since you've been introduced to graphing conics correctly and visualizing where they intersect, you can at least follow with the logic behind trying to find those points of intersection, okay? So guys, look what the note I made. Homework. There is none, good news, but to get some points for doing this work and earning a little bit of credit, just send me a picture of these notes that you took as you followed along, and you will get 4 out of 4 for today's grade. So you'll get a daily grade of 4 out of 4 by just taking a picture of the notes you took and emailing those to me. Once that's done, you're all set for the day. We would start a brand new unit tomorrow on Friday, April 17th, and we'll head to our next section, okay? Thanks a lot. Great job. See you tomorrow.